In this lecture, I want to discuss some other ways you might generate multi-step forecasts. You may have noticed that the two forecasting methods we used in this section demonstrated some pretty extreme results. On one hand, we saw that one-step forecasts can seem artificially good, especially when all they do is just predict the last value or close to it. On the other hand, doing a multi-step forecast iteratively, using the model's own predictions, can lead to poor results, even on simple problems like the sine wave. Even a nearly perfect sine wave model eventually breaks down due to the buildup of numerical precision errors. At this point, one issue we have to think about is practicality. In fact, it's not necessarily wrong to predict only one step ahead. It's certainly wrong when you want to make a conclusion such as, wow, look how good my model is at predicting future values. Of course, that doesn't make any sense because you used future values to predict future values. In some cases, it may make sense to only want a prediction for one time step ahead. In other cases, it may not make sense. For example, if you want to forecast weekly or monthly sales for the next year, it doesn't make sense to only do a one-step forecast. On the other hand, maybe you just want to predict the load on your website for tomorrow, so you know how many Amazon machine instances to spin up. Either way, the method you use is highly dependent on context and the real-world constraints of your problem. It's also important to benchmark your predictions against a baseline model. The reason you want to do this is, well, what if your complicated model performs worse than your baseline model? If that happens, then you should just use your baseline model. As you'll see, sometimes you can even prove mathematically that your baseline model is better than your complex model. One way to establish a baseline is to use what is called a naive forecast. A naive forecast does the dumbest thing possible. You guessed it, it just predicts the last value of the time series. It's a model with 0 parameters. One interesting fact you will learn about if you ever study finance is that stock prices very closely follow a random walk model. In a random walk model, a naive forecast is in fact the best forecast you can make. So by definition, if your time series follows a random walk, it doesn't matter how complex your model is, you cannot beat a naive forecast. In time series literature, classic statistical models such as ARIMA use algorithms that predict only one step ahead and then use the iterative method we discussed previously in order to do multi-step forecasts into the future. One interesting question to ask is, are there any models that naturally predict multiple steps into the future? The answer is yes, and we can do so quite trivially. As you know, it's very easy to specify the number of outputs in your neural network model. You just pass in a number into the dense layer for the number of outputs you want. So what if you want a model that predicts 12 time steps ahead simultaneously? In fact, that's entirely possible. Just make a neural network with 12 outputs. Then, as the target, you'll use the true values for the next 12 time steps. So whereas in this course, the target just had one value, for a multi-head model, you'll have a target with 12 values. If you're interested in this kind of thing, you might want to give this a try as an exercise. To summarize this lecture, what we wanted to do was clarify the difference between the different kinds of forecasts. The big mistake a lot of people make is they pretend they are predicting the future, when in actuality they are only predicting one step ahead. It's not wrong to predict only one step ahead, but you must be clear about the results you are presenting. If you really want to forecast multiple steps into the future, then you are not allowed to use data from the future. Of course, there are some cases where you actually want to make one-step forecasts only. This is dependent on the specifics of your company and your data. Only you know that, and you must design your model accordingly. We also discussed the importance of establishing a baseline, which in time series analysis is often the naive forecast, where all we do is predict the previous value of the series. I mentioned that in a random walk model, which often very closely models stock prices, a naive forecast is the best forecast. In addition, we saw that aside from building a one-step model and then iteratively applying it to predict multiple steps into the future, there is an easy modification. We can simply use a neural network with multiple output nodes representing the multiple steps in the future that we want to predict.